So I trust you can see my screen. And we'll quickly go back to, okay, thank you. So basically, I was just talking about this slide, right? And this first slide is basically, I think I spent some time talking about what we are focusing on in this lecture or this week. We are focusing on precast walling system, right? Now, I said to you as well, these elements, you can see this wall, like they come in panels. They don't come in full wall length. They can't really crane it and lift it to this final position. So the engineer and the architect will work together how to cut them into buildable pieces. So they're going to work out how to cut them. The engineer, architect, and the builder typically meet together before they start manufacturing these things in the factory, because the architect would like to decide where the joint going to be to look nice. And the engineer would think about how they're going to be calculated and work out the design for the panels. Like, for example, the engineer will think about requiring a rebate here. See this rebate to allow for this panel to sit on it. So in terms of naming this system, it can be called precast panels. Panels comes from, we have, you know, panels units forming the full wall. Sometimes we call them tilt-up panels. Tilt-ups coming from the concept of having these panels built next to its final position, not exactly on its final position. For example, we will talk about this part here. There is an image coming. Here we go. So this is one of the construction types. Is called stack casting, where they're actually going to be stacking, whether single casting or stack casting. Sometimes they build those panels next, like in the site, but not in the final position in situ. No, they're going to build them next to the site, and then they're going to tilt them up to their final location. So there is a construction method like this, where it depends on if the site is in the city, which you can't do this, you have to build them outside in the factory and bring them piece by piece. Or if you're building something in a farm, like a storage or a warehouse somewhere in a farm, and it's too costly to have all those panels transported, it can be cheaper to build them next to its final position than just tilt them up. So I'm coming to the point that these elements are also can also be called tilt-up components. That was just a naming. Well, I've also mentioned to you as well that these walls that you see here, yes, they can be, the walls can be built as in situ, no issues. But again, that will be slow, gonna reduce the speed of construction, because if we need to build those in situ, then we're going to need first to place the reinforcement, and the reinforcement can be single layer or can be double layer. And then we need to put a formwork, then we need to pour the concrete, and we need to vibrate the concrete, we need to cure it, its time, its cost. And there is such systems typically, they don't use in situ. In situ is only used for special features where you have to build them on site. Maybe if you got one like few walls in a building, you may think about building it in situ. But if you have a warehouse which most of its surroundings are precast panels, then nobody will build it as in situ, right? So also what I was talking about in terms of this slide, it is the components of the panels, or the tilt-up panels, or the precast panels. There are many components, as you can see here in this slide. Now, those components, they can be purely for the construction process, like this number 3 here. It is the edge lift anchors. Number 3, if you go to the next page, you've got the naming for each component. And number 3, for example, it is the edge lift anchor. That's purely placed to for transporting the panel, because that's how we're going to be craning the panels from these kind of anchors, right? The other one I was talking about, ferrules. Ferrules, they are little sleeves pre-installed in the precast panel, and they are purely there to allow for fixing the props. These are the props. These are propping system. These panels, as you would understand, it is when you build them and tilt them up, they have to be propped or temporarily braced until we will be fixing the roof somehow with the roof structure. If this was a single story development, here we're gonna have a roof. And these panels must be propped as per engineering until we have actually constructed the roof or the first floor. Maybe in your case, in your assignment, you're gonna have a first floor as well to think about. So you can see sometimes the ferrules as what we have here. We have also ferrules here used to allow for installing the a steel tie. This steel tie, it's used for permanent consideration. So again, the ferrules, whether the ferrules or the propping ferrules, these ferrules here, or the end anchors, they are just elements or components which are temporarily used just for lifting or temporary propping the panel. But these ferrules here, they are permanently used to tie the panels together and allow for constructing the roof purlins. Remember the purlins we talked about in the portal frame? Same thing here. We can install roof purlins, and those purlins going to be supported on this tie, which can act as a beam to carry the roof as well. It's up to the engineering drawings what they want to do, and we will have real examples to talk about different cases as well. The ferrules here, you know, to fix this bracket, this equal angle bracket, there are ferrules back here, and those ferrules will allow for permanent connection. This is again a permanent connection. So in summary, what I'm trying to say, some components you see here, they are for permanent use, and some components are for temporary use. You just need to understand this. Then after I talked briefly about this slide, I jumped to this picture just to show you guys where you were not seeing what I'm showing, just to tell you, just to show you a picture for how we connect the prop to the panel. But as discussed, those props will be taken away as soon as we build the roof and get those panels stabilized. And then those ferrules will be capped by a piece of plastic, which is provided by them. They cannot leave it permanently open. They typically get to cover it with special covers provided by the suppliers. Now, at this point here, that's the point where we're connecting a permanent steel beam. This beam maybe forms another floor in the building. Yeah, it looks like the panel is higher, so the roof is somewhere here. But this is basically forms the floor, maybe a first floor. And how we connect those steel beams to the wall is by either using same thing, the ferrules I was talking about, or sometimes we can have a cast-in plate with a U-shaped bars embedded in the wall. And all these kind of components are pre-placed in the formwork before pouring the concrete for the panel. So that was where I stopped, because seems that my slide was not shown. Now, while I talked to you about the cast in place, this is just an example for the plates ready to be placed in the formwork before pouring the concrete. So that's just the back look of it, right? The front will be just a piece of plate like this, where we're going to be welding a cleat, and the cleat will be fixed to the steel beam. All right. Now let's go back to where we to this image. So the details or the naming of these components are all here. Now some students are going to ask me, do we need to memorize this list? The way we're going to ask you questions about these components is we're going to give you again a picture or image and ask you to tell us what's this and what's that. That's one of the way we ask you. Or the other way how we ask you is what we're going to do in assessment 2, is we're going to give you a number of components, and we just ask you to tell us where that component going to be used in a given drawing. So we're going to practice this slowly during the workshops, and that's basically what you're going to be doing as well in your second assessment. Is we ask you to give us elevations, then tell us what we have to use in order to build or construct tilt-up panels or precast panels. Right? There are some components which, like this one here, this is basically used as a as a bond breaker, which it's used only when we are constructing the panels next to its final position. Bond breaker, we're talking about, you know, those which I think, yeah, I've talked to you about this slide, and I was saying to you, there are situations where the site is very far from the city and far from a factory to build precast panels. So the builder will decide on building them on site. And when they build them on the site, they don't build them one piece by one piece. It's going to take too much space and you may not have it. So what they do, they stack them on top of each other. And the stacking got two types. One is single casting and one is stacked casting. So with the stack, that's the stack casting, what they do, they put them on top of each other. And before, so they build the first one first, and then they're gonna spray, after the first one gets hard, they're gonna spray the bond breaker. So it's gonna create like a film to separate the first one from the second one. And that's why that component was shown to you in that image. So that component is used. It's just shown in that image by the supplier to explain that they have such product if it's required. Right. Just to let you know, this image is just taken from one of the suppliers, and all those they're claiming that they can produce those different components. If you want to construct things near to its final position, they have this available. So that was just. Remember, there are different companies who can provide panels and their components in different, slightly different products, but they all doing the same job in the end of the day. Right now, yeah, I think we don't need to worry about this part. These are just control joints, which you know about, but it's not really something that's part of what we're talking about this week. We talked about these things in our industrial slabs topic, right? There are more components we will talk about more components as we go through the slides and as we go through the workshop questions as well. Yeah, so let me keep going. And what I suggest you when you study this, have a look through all those orange texts you see on the slide and make sure you understand what they're doing. And what we're going to practice together in the workshops, basically, that they will be the components that you will be using in your second assessments and asked about. All right, so the next slides here, we'll talk about component by component. And this slide's talking about the anchors, which are pre-placed in the precast panels. As I said, they are for temporary use only. For example, we have a facelift anchor and we have an edge lift anchor. The edge lift anchor, you can see the supplier can have the indifference rating. Depends on how heavy the panel going to be. They're going to use a stronger with more embedment into the concrete. And basically they are, you see this one, these are all 3D images just to let you imagine how it is constructed. This component, the edge lifting anchor, you can see that's how it's placed, but it needs other arrangements. For example, this shape here or this element, it's basically there to create the void, because you need a void that will end up showing you the anchor point. So there's going to be this anchoring point where they're going to put the the chain and lift the panel. This is edge lift anchor, and you need to know there is some types or sometimes where we have to lift the panel from its side. Now, an example for this, I trust we have it here, or next week. Let me have a look, just to show you how we lift. Here we go. So you see this type or this image talking about face lifting. Sometimes we will talk about this as we come to the end of today's lecture. Sometimes we're not able to carry our panel from the edge, like what you see here. We can only do that from the face for reasons we will talk about later. So what we mean with edge lifting, when you're going to be lifting the panel from its very top, for example, or side, so from the edge of the panel. Sometimes we can only lift it from the sides, maybe 2 points or 4 points or even more, for reasons we will talk about later. But basically what I wanted to show you is just to understand what I mean with edge lifting or face lifting. If we have edge lifting, we're going to be using the edge lifting anchor, and I will go back to it here. So that's the edge lift anchor, and they need to be placed before pouring the concrete. And we're talking here about the facelift as well. So same thing. There is this act as a chair, basically, just to help you to have it placed in position and firmly placed in position, because when you pour the concrete and vibrate, things may move off away from its final location. And as I said, this part here is just going to create the void. So when you pour the concrete, then you can just knock this face away, and you're going to see that hole to place your anchoring point at. All right. Right. So here we talked about the first components. Their location were somewhere, as I said, you've got a face lifting. They can be these guys here, so face lift anchors, or they can be at the edge, which is, as you can see here as well. I trust we have more details about the edge lifting and face lifting. So basically here, the suppliers, they're saying we can have 2 holes. It depends on what you really need to do and what the crane people want to use. They got 2-hole anchors, and you've got spreaded anchors. Basically, they're going to provide you with different capacities. If the panel was very tall and very heavy, then you would use high duty panels. This really all going to be now depends if you are managing a project where you're going to be kind of looking at the whole building as a builder for the whole building, then you may not be worrying too much about those details, because they will be built in the factory and different contractors going to worry about such details. However, if you're going to be on a project where you want to build those panels near its final position, like the stacked casting, then you would need to understand those components and which ones to use. So that's where you need to go to the suppliers' manuals and work out the weights that will end up be applied at each point, and find out whether this anchor is adequate or not to do particular job, right? It depends if you're going to leave that to the contractors or you're going to be doing it. You just need to understand, if you are in a position to decide on a connector, you have to make sure it is correctly rated, right? You have to make sure it's correctly rated for the particular loads it's going to be under. Right, and as I said, what we're seeing here is just a product from one supplier. Those products can slightly change from one supplier to another. So this image here, or this slide, shows you after pouring the concrete and after the concrete get to its hard status, how they can lift and take away the void, because they want to see this is a face anchor, and this is basically the void former, and they're taking it away to end up allowing for the crane to be connected at this point and lift the panel as required. So this is again the void former, and that's basically how it's removed. Now, if this is not part of your packages you need to look after in the construction, you may be, as I said, managing the construction for a building, so this is going to be Most likely, if you're building something in the city or in a place where you can't get those panels to be built near your site, then most likely it's going to be all looked after by the engineers or the people who are really going to be working in the factory. And you won't be involved in such details, but you just need to know them because they're going to end up responsible about building it and craning it to its final position. That's it. You, in that situation, you will be worried about making sure the panels are looking correctly at the shop drawings, which we're going to talk about, and making sure things are installed as per the engineering drawings, which you're also going to practice for assessment too. If you were the engineer who works in those factories, then that's where you need to understand the details we're talking about and the different types and ratings and use. Okay. This image here takes you more into the real positioning and placement for those anchors. So basically, can someone tell me what was this you're seeing here? Can someone tell me what's this? An edge lifting anchor or face lifting anchor? This one here. Yes, that's right. So this is basically a single panel which you are building on site. So maybe you're building a warehouse somewhere in the middle of a farm, far away from the city, and it was decided that you're going to be building those precast panels near its final location. Then after they get ready, you can tilt them up to their final location on top of a strip footing. So coming back to, can someone ask me what they think this part is? So can I ask what this part is? What's happening here? Just to see if things are clear for you guys. What's this here? Okay. Reassess. This is any other tries? Other students? What's this? What this part? So I can expect there are panels gonna be like this, poured around, but what this gonna be? Got an answer saying this is a reassess. Drop-in slab. No. What's drop-in slab? This is not a slab. This is a wall that will be tilt up. What they are doing here, what they're thinking about doing in this part here that I'm crossing. Void, that's right. It's like for a door. For a door, right? So they decided to have this like a U shape, inverted U shape, precast panel, and they're just creating a door or opening. A door or opening in the precast panel. No, it's not to reduce weight. It just maybe it's not to reduce weight at all. It's just maybe a precast panel. Let me see if we have this case. No, we don't. So maybe the engineer here. So in this case, the door was formed in a different way where they had a panel, two panels on the sides. And then they decided to have a panel sitting on a rebate. This is a rebate here. But the one that we were seeing, it looks like the panel was forming the door inside it. So it was something like this. Yeah, is it making sense now? So this was the one we're seeing, for example, laid on the floor. And they're building it. So it's like something like this. Did it make sense? Any question? So the one I'm framing to you or drawing to you on this images was basically another panel still on the floor. And that's definitely, it's up, as I said, Maybe the architect didn't like to have a joint here. Someone will ask me why this is happening. Sometimes they have a fancy entry to a building, and as I said, deciding on the joints, they're going to be permanently viewed. It's going to be happening during the design documentation process. Architect, builder, and the engineers will sit together to see if it's doable or not. Okay. So maybe something like this is acceptable for a warehouse, maybe not for a fancy hotel or whatever you want to construct. So yeah, I think this slide is talking about a real image for an edge anchor, which I think you've answered already. You know, this is at the edge. So this one here is maybe located somewhere here. I think if I zoom in, no, I can't see. So maybe it's located somewhere here at the top of the wall, right? And that's how they're going to be lifting this when it's poured and get hard, right? Now you can see in this, again, this was a void as we discussed. And here you can see the single mesh. You can see here tubes, which is for the electric piping if they have any electric wires. You can see they also use the chairs to make sure the mesh is actually placed in the middle of the formwork, which is in the middle of the gray concrete as well. And as we go around and around, I'm sure you will see they will be placing ferrules. You see that these are the ferrules that they have. Maybe, as I said, they can be for temporary use or permanent use. You can see here after that's basically the end it's a panel, which looks to me it's on the side. So this is just the end anchor where they took away the void former. These voids are for dowels. Now this one basically it's on its side. It should be lifted up somehow. Okay, I'm not 100% sure about its final positioning, and you may not. Just to let you, these looks actually very, very fancy because I trust you. I will not judge you about this because this is your precast panels. You see, this is maybe 150 thick or 180 thick, and I can see there's a nice feature. You see all this? This is just a feature. They want to have that nice curving. So basically, we're seeing the panel here from the side. They still place them, making them ready for a truck to take them, or I don't know where they are taking this. But someone may look at this carefully and tell me, what's this? Why here we've got a curved? Look, this is just a finish on the face of the panel, maybe some curves or special features, which you can see in many buildings around. Usually they make those features like they are non-structural. They will have their own reinforcement and detailing, but they are not structural. The structural part, which will be carrying the forces and actions and stresses, it's here. It's within this 150 thick. Okay, it looks to me like this panel got some special features because they're putting it in the facade and they want to have that nice look. But not all of them gonna be like this. It's only maybe the ones which is facing the street and they want to have this special look. So yeah, these things can be extra happening. All right, so these are just some real pictures taken for panels during the construction process and after the construction process. Again, this image here is talking about the ferrules, which as I talked to you before, they can have different functions. One of them, you're going to be fixing the props into your panel, or the other ones is you can be facelifting the panel by using them. And again, there is a special bolting technique that you would need to be using inside the ferrules to actually get them installed. So basically, again, if you go to a project, you start working next year a project, I can tell you they won't be all of them like this. They are different products outside, but they're doing the same job. They're all ferrules that will allow for a screw to come in and get something fixed to it. That thing can be for temporary use like props, or something can be for permanent use like that roof tie I showed you before. All right. Now, those chairs or those fixers, they are there, which will need to be fixed by standard connection, and the suppliers for such products will give you such guidance. So they have tested their components very well to resist and take whatever forces the engineers will require. Just the way how it works, each components we see here, whether ferrules, whether cast-in plates, they are rated. They are rated. I think that's what's written here to us. So that's what I'm basically talking about. They are rating for particular shear force or tension force, right? And the engineers basically, when they design precast panels and detail them, they're going to look at such books and make sure the forces they calculated are less than these capacities to make sure everything is safe. Yeah, if you're going to be the engineer who's going to be constructing those panels, you may need to have some deep knowledge into such things, because what you're going to get from the engineer are forces, and you need to make sure the forces that the engineer was asking for, they are less than the capacities to make sure everything is safe. So again, this was just a ferrule connection where we use them maybe most likely at the base of the panel. Here we looking at another type of bolt. We can use this one, just shows you there are situations where maybe the void was not placed in the right location, or maybe you did not want to do it. So there are decisions where you're going to be, the connections are permanent and you want to use mechanical anchors. So you won't allow for this ferrule. You will just come during construction and install what they call a true bolt or a dyna bolt. So you're just going to drill a void and then put some, clean the void as shown here, and then you're going to install your dyna, or they call them sometimes dyna bolts or true bolts. They have got, again, different capacities. But the point is, sometimes if maybe the voids are accidentally placed not in the right position, the ferrule I mean, or maybe it was decided not to use ferrules, they're just going to be mechanically installing bolts. That's another option which is possible to do so, right? Talking here about another component, the dowels and dowel pockets. Where is this located? They are typically located at the bottom or top of the panel. So that's how we connect the panel to its strip footing, right? This is a different connection, but what we're talking about, basically when we connect the panel to the strip footing, there are dowels. And to create a void for such dowels, we can use such void formers. So that was here. So a dowel pocket, it will allow you to allow for a void or pocket where the dowel will be installed in, and then you will be putting some grout to fill it with grout. So below each panel, there are some voids. I think we've seen that here. There can be some voids to allow for a dowel to be placed inside. The size of those voids can vary. Depends again on the product you're using, depends on the engineering design. So these are just some voids allowed. Remember that was different, something else, that was the edge anchor, but there are sometimes voids we need to allow for in the panel. And the dowels, something similar to what we talked about in the joints, right? If you remember the word dowel. So when we're going to be lifting up this panel and placing it in position, the dowels will have a room to be lapped inside this void. To allow for this void, there are various products. One of them, something like this. This comes in a wider positioning, and to allow for more room, to give more room for inaccurate measurements. Because as I said, if things didn't work out, there's a lot of situations where the builder will call the engineer and say the dowel was not really located in the right spot, and basically you can end up using drill and epoxy, because sometimes the dowels are very small in size, but you have the room to have them much bigger if you use this product. But everything comes with cost. You know, if you're going to be using these products, they are more expensive than using just a tube to allow for the dowel. Now, after you install your panel, you have to grout this void. I will show you more engineering drawings, maybe if not today, maybe during the workshops, to let you imagine how this is all working. So basically there is a void, or maybe if I have it ready, I will just open it. This is the school example project, which we're going to visit again. You know, remember this project where we talked about the basements and the board piers? If we go to the end, this project got some, here we go, that's what I'm really talking about. This is the dowel, that's your precast panel. This is how it's fixed to a strip footing. And this is basically the dowel component, N20, right? Now we have to allow for this void, and they can come in different sizes and different forms. So this void, it was the part I was talking about and how to allow for. And remember, after we place the panel into its correct position with a dowel, we have to fill the void with a grout. And that's basically how we do it. So after you put the dowel, we're going to fill the void with a grout from the top. And we will talk about this detail and how it's used. All right. Now, this is just a pin connection, and this is the fixed connection. Depends again on the engineer design, what he's asking for. So going back to our, that was just a grout tube to allow you to fill that void I was talking about. Now, a different component here we have listed is packing shims. They basically, there are a lot of situations where your strip footing, the strip footings which supports your panel is not perfectly level. So we use this kind of shims to get your panel leveled. Right, and then you still can grout in between it. You can put grout, but you can't put grout and level it up during the construction day. Well, while you're craning these panels, you have to do it in a timely manner because you have to finish a number of them in one day. So we use those shims to level up the panel, and it is available in the market as well. As I said, most of those components were taken from one supplier, but they are different products. You can see the shims, they come up with different thicknesses as well as required. Okay, so this is purely for constructing, for a temporary use during constructions, but you need to understand that you still gonna grout all the below the entire panel to get things correctly supported. Cast-in plates. Yeah, cast-in plates, they are basically used in or at the points where you want to fix a beam to a panel, like what I showed you here, for example, this one here. Yeah, I'm just zooming into it. You can see here, for example, this is a different story here. We are connecting the steel or supporting the steel on top of another panel. Maybe it's getting a lot of load. That's why they created another panel for it. But here you can see there's a steel beam which is fixed to a cleat. So there is a cleat here with maybe 2-3 bolts, and the cleat is welded to a plate, and that plate is cast in. So in the back of this plate, you got those U-shaped bars. If you want to imagine it in a different way, have a look to the engineering drawings I will share with you. So we gave you, and we're going to discuss a lot of details. For example, have a look here in this project. Here we go. So you can see the side view. This is just the front view. So that's the plan view of a cast-in plate. It's one of the types because, again, it depends on how much force it's taking, and the engineer will be asking you to put CP3 or CP2. CP2 seems to be more decent. It's carrying more load. Now, there are those U-bars welded to the back of the plates. Sometimes we can use ferrules, as I said, it's up to the design engineer, but you're going to be working with these drawings, which will tell you what to do. So you've got the size of the U-bars, the details of installing it. You're going to need 2 here. The plate size is this much, so it's all given to you. And after you have this pre-installed, they're going to be a stiffener plate, maybe 12 mil thick, welded, and then you will have 2 bolts or 3 supporting your steel beam. Okay. That was just a front view, which is view BB. It is just here, and that's just a plan view. You have more decent connections as shown here, and there is even more heavy duty CP1, so that's got more embedment length of the bars. Yeah, we need to make sure the funnel, the reinforcement, is available. So you can see here at the corner of your bar, you have to allow for 2 bars to be installed here as well. Okay, so that was to do with precast. As I said, they come in different sizing and shapes. We will be talking about this elevation. That's gonna be part of what we're gonna practice during the workshop. So, and we'll take you through what we're doing here and what we're talking about here and all the detailing. So we will talk about the details of these drawings during the workshop Wednesday, right? Because that's basically how it's engineered for the builders to build, and we will talk about them. Now we're just taking you through the notes, back to the notes, and we were talking about the precast. Yeah, so they're just having those ready for you to place if you are building, if you are constructing or like if your role is to construct these panels, whether in the factory, I don't know, maybe you're going to be working as the construction manager for the panels in a factory, or you may be doing it next to its final position on site. But this will happen only if you're building a warehouse far away from the city and it's too expensive to transport the panels. But if you're going to be managing the construction of a school in the middle of the city, for example, you won't be dealing with those panels because they are already inside the panel, and the panel going to come to you craned and ready, and you still have the role, or you still are required to make sure everything is placed. You're going to be checking what we call it workshop drawings, which I will come to later on. So depends on what your role is. Right, so planning for tilt-up. So we've done kind of the components. So the components that we visited individually, make sure you understand them. They're going to be most likely what you're going to be asked for, and you can look at all the other components and ask me about if you have any questions. We will maybe talk about more other components or coming in different forms and shape when we go through the workshop. Like when I talk to you about these examples, we may talk about different components. So whatever we practice together can come to you. Any question someone would like to ask? All right, let me stop here and give you a break. Say 9:15. Yeah, I will continue just for a quick break. And if you have any questions about the components, you can ask me. After we start 9:15, we can talk about planning for the tilt-up panels or precast panels. Okay, let's keep going. So we covered the components, and we talked about several components. As I said, make sure you understand their use and other features. We will talk about more components during the workshop as we start working with some engineering drawings in relation to constructing the panels. Now we'll talk about the planning. We go the slide here lists to you a couple of main considerations. As I said just before, a couple of times, deciding on the size of the panels and how we join them, they have to come from different sides, not only from the construction engineer or the structural engineer or even the architect, because each individual should have their own inputs here. So it needs to be worked out during the planning stage or the design stage for the development. So there are two aspects. They need the continuous involvement of each member, as I've also mentioned, because the final look will be up to the architects. The costing and the buildability, it's up to the builder or the construction engineer, and whether the size of the panels and the reinforcement level and the connection details, it is up to the structural engineer who's sizing up and detailing those panels. Yeah, they need the design method. Yeah, sometimes you will have a special method. For example, let's talk here about one of the situations. Sometimes the size of the panel will be limited by things nothing to do with the building itself. It's maybe with power lines. So if you have, for example, in this, if I take you back to this school example, right? So we have those panels. Some of them are tall, like you see this panel. We'll talk about this carefully. This is one of the panels here, and you can see this panel is quite tall, right? It's going from, which is, I would say this is 3 plus 3 plus, so this is going to be up to 8 meters high, right? So one of the issues that you may face for constructing it is how you're going to be lifting it up, especially if you're making this development in the middle of a suburb, a developed suburb. Why? Because you have the power lines. So if I just give you an elevation, a quick elevation here, this is, for example, the street. That's the street. And that was just the footpath, the nature strip, and the footpath, and then you've got the site starting, that's the boundary line, right? And then after the boundary line, let's say you've got maybe 3-5 meters, then that's where you want to put the panel, right? You've got maybe another 5 meters to put the panel. That's the final position of the panel. One of the issues you may find here is you're going to get the craning truck here, and you want to lift the precast panel. You got the precast panel here, you want to lift it all the way and place it here. One of the challenges you may face is you've got power lines. You know the power lines, the cables which runs in the street. They may cause you a big issue here. The solution is you need more expensive crane to go even higher. And given that here you've got 8 meters already in height, you have to go 8 meters plus whatever height. So it's going to be really high. You have to get maybe the crane. You won't be able to have that big crane within this street. So there's a lot of issues. You may think about what the facelifting I was talking to you about just before. So you've got an option of facelifting, because with facelifting, you will have the opportunity to, I was think one of the slides, here we go. So when you have a facelifting, you will have the opportunity to reduce the kind of the lifting height of your panel, right? So if you're gonna allow for 4 points, you can cut down the lifting height by half, and that will let you go over the power cable or trees, right? So that's really the challenges. The structural engineer cannot think about this alone. The architect cannot be thinking about this alone. The members needs to go to site and think about all these components. Okay, and okay, the construction engineer is the member who should be thinking about how things going to be taken from the design into the real placement of the panels. All right, so that was just a situation where a continuous thinking for constructing and building components need to be thought about. Yeah, the economical side again, as I was saying, taking you through the lifting process, the crane lifting process. It can compromise the cost, it can compromise the doability. That example of craning the panels from the street, you need to go through approvals from council as well. And as I said, if you're going over a power line for safety reasons, the power authority will be required to shut down electricity temporarily, and all that's cost to get approvals and let this all happening. Yeah, in many situations, the power lines needs to be shut down to allow for taking such things above the power lines, because to prevent any risk that can happen from there. So to achieve better economical outcomes, make the panels as big as it can be handled by locally available equipment, and that's what we talked about. So sometimes you need to size them down, sometimes no, you try to maximize them, but make sure the on-site conditions will help you to do that. Okay. Standardized panels. It's better to go with simple shaped rectangular panels as big as you can crane them in terms of the weight with economical cranes. You need to have a careful planning for the construction, the time, as we're going to talk about. If you have the two main types of constructing those panels, as I said, they can be done in the factory and get craned to you. That's got its own cost. But sometimes if you want to self-source it because you're building those panels in a farm far away from the city, you may think about stacking them next to their final position, and you're going to be building them there, but that means the cost of constructing them will be cheaper because you don't have them ready for you. You will be doing them by your own, so you need to manage all the time and labor for such arrangement. Yeah, that's what I was saying. You need to work out whether they have to be done on ground rather than when they are being erected. So there are a lot of works. What we're trying to say here, try to put all the connection detailing in the panels while you're building them. So avoid using the mechanical anchors. Try to make sure it's going to be built like a Lego. So all the fixing, all the ferrules, all the casting plates to be placed in the right position and as much as you can. Now, if someone gonna say, what about if I missed placing those? Yes, there is a way, but you're gonna end up needing a special design where you have to drill an epoxy. So if those casting plates were not installed in the right position or missed, that's where you can do use a drill and epoxy and doing it after you actually lift it up, but that will cost you more time. It will require design, it will require scaffolding to allow for the people to go up and do all those connections, so it will slow you down. That's what this point is saying to you. As much as you can, try to place all the details and the fixing details before actually pouring the concrete while the panel is on the ground, or while the panel is actually in the factory. Try to put all the details and fixings pre-installed in the factory. That's where careful review for what we call it shop drawings must be done. Because as I will show you later on, there are what we call it shop drawings. Shop drawings, they are kind of almost ready to build drawings that not the engineer will do. So these drawings I'm sharing with you, they are not shop drawings. They are just the engineering drawings. There are more detailed drawings that a draftee will do with experience of building such. There are draftees which got experience in building such panels. They will be creating those shop drawings, and the shop drawings will be reviewed by the construction engineer to make sure all the ferrules are placed in position correctly, all caster plates are positioned correctly and placed correctly, so things will smoothly go. That's what we're trying to say here, to achieve a correct and smooth programming for the construction process. Access, and I think I've given you a very decent example about access. The power lines surrounding your site can impact your access. Having trees can impact your access. Do you have a basement or no? That's where you need to allow for a ramp to go inside, then a crane where you have to crane. So think about the access and the transportation, the logistics behind the construction process. That's all needs to be timed and thought about to prevent needing extra time to build such panels. And then you're going to compromise the point of using precast. Precast panels, definitely, they well known in saving the construction time. And if things were not planned correctly, in terms of what we covered here, or in terms of the access, that will compromise the advantage, the timing advantage. Layout and casting method, as we said, there is, first of all, you're going to decide if the panel is going to come ready from a factory. That's if you're building within a developed area. If something outside the developed areas and it's too far to get those precast panels built, the cost will need to be worked out, and a final decision can be a final decision can be made. It all depends on how close to their final position are. And avoid having the crane to be moving from one spot to another, because the crane itself will need time to set up itself and get ready to start craning. And as you know, there are more complications. So it's always your decision to think about the correct positioning of the crane that will end up installing as many panels as possible. Okay. We'll also need to consider the weather. If it's too windy, like what we had 2 days ago, it won't be a craning day for you. You should delay it, because there is a risk and safety issues there, as well as the positioning of the panels will be difficult to achieve with high winds. Operation. Now, if we're talking about especially those on-site or near final position constructing, you need to think about how to construct. So typically we construct from inside out, right? If the crane is operating from inside, it may be necessary to omit one panel. So you have to think about the final exit for the panel. So in case maybe you don't have space to go outside in. So let's say if this is your, let me see if I got some space to draw something for you. I'll draw it here. This is your site. The green line is the precast panels, and that's the boundary line. So this is a precast panel, and this is your boundary line just within this space. So in this case, definitely you have to crane from inside. You're not allowed to go outside, but you have to allow for some panels, to stay after you get your crane out. That means if you have a street here, for example, you have to get permissions from council to shut down the street. And you have to worry about the power lines that may be here or trees that you may have outside. So always think about, try to do them from inside out as much as you can, because it will give you the freedom of making decision about where to place your crane and how fast it can be. But always allow for keeping some panels to go out and do the final, place the final panel. Same thing when you have a basement, you have to allow for the ramp location as well. The ground earth ramp that I think we talked about before when we talked about constructing basement. There should be a ramp to allow you exit, to allow the crane to exit out from the basement. If you have your walls as a precast, like the case we will discuss for your second assessment. Right, so we were talking here about the layout and casting methods. So part of the planning as well, as I said, if you've got situations where you want to build the panels near your final position, there are two types: single casting and stack casting. The single casting got advantages over the stack casting, and also got disadvantages as well. So single casting, no space casting paths are required. So we got some slides talking to you about the formwork details we need to do. If you've got stack casting, you need a special formwork. You need the bond breaker as well, we talked about before. You need more arrangements than what single casting will require. It's only simple edge formwork because it's single precast panel. The precast panel can be 180 thick, 150 thick millimeters, 200, 240. So you just need that single formwork to do. So it's advantage. And range of surfaces can be achieved. As I said, sometimes we got special features in the surface, special looks like grooves, or like what we had here, for example. You remember this picture I was talking about? When you see this panel here, I can see this is your main structural thickness, but they got special finishes outside here. You can definitely, if you have to build this on the side, you can only do it when you have single casting process. So that can be an advantage. So sometimes the finish can be only a rough face. So as simple as having a rough face or some lining, architecturally it was required. So if you have a single casting as well, they're going to be units, you can end up building them very close to their final position. Unlike stacking, you need to spread them away. So it's going to be the crane that you would need to use quite small and less cheaper or more economic to handle and operate. So that was the advantage of single casting. Disadvantage is surface or finish of the floor location. Single casting, again, it may have impact on your ground because construction will cause some roughness to the ground itself. So that will require you to maybe repair or maybe restate again, because you're going to be using most of the space to do those single casting. And conflict with corners. Usually, if you're building different, there's always some tolerances, so you won't be getting the exact same sizes in every pour you do. So you may have issues with the corners, which you're always going to need to require, because the dimensions won't be perfect 100%, because the formwork, you can have many formworks. You may be missing 3 mils this side, 5 mils the other side, and that will end up having issues at the corner. So that will slow you down as well, which can be considered as a disadvantage. On the other side, stack casting, with the stack casting, again, this conflict won't happen a lot because you will have 5 built or 7 built in one go. The size and dimensions will be exactly same typically. So the corner issues will be mostly avoided. Talking about the stack casting advantage, can be processed independently of the floor, because you don't need to use most of the space there. You can have smaller space to occupy and use. It will allow you for more flexibility because, again, as we said, we're not using all the space. You can move around and move the positioning for the crane. It's up to you to decide on the positioning of the crane. By the way, this is from a document from a supplier, which gives an idea to the builder. So it's not one method to build it, but there are different ideas. And at the end of the day, it's up to the construction engineer to decide on placing the priorities and which one to start from. They can change from one to another. These are just suggested by one of the suppliers for panels, just to help in having ideas. Okay, so talking about the disadvantages, you will require to separate you have to use and allow for the time to use the bond breakers. The one I was talking about, you need to spray between one panel to another to create a thin film between each panel or another. Otherwise, they're going to get stuck to each other, and it's going to be not possible to separate them when you want to create them away. You're going to be very limited in terms of the finishes you can have. You won't be having a finish. If you have a special finish on your panels, you won't be achieving such a. You're going to go. So this is faster, more flexible, less occupying the floor of the property you're working on. And yeah, the issue is with it's going to be more arrangements needs to be allowed for to separate between the panels by using the bond breaker between them, right? So the height for stacking the panels and building them on top of others. So there is ideally up to 900 millimeters in height. So a little bit less than 1 meter to allow for a proper formwork. So the formwork I'm talking about, I think we do have some slides like this one here. This is just a formwork. You can see the formwork for this is basically a formwork for stack casting. We have here 1, 2, 3, 4, 5 panels, and ideally you will need more rigid framework, more costly framework to happen around the stacking, the stack casting process. And ideally, as per that last note, it won't go more than 1 meter in height. Otherwise, it's going to be much more work to do, and it may be compromising the quality of the panels as well. It's going to cost you more time to go higher, so you just need to go to another position and get it done. This formwork is for single casting process, so you can see it's much more less work to do here. Right. Just back to the notes. So that's again the point I mentioned to you. After you had your panels getting to its construction stage and cured and ready to be lifted, so they're going to be lifted up by whatever numbering. So you can see this is one of the, as I said to you, these kind of placement or arrangement for placing the panels are suggested. They definitely can be up to the construction engineer and the situations they got on site, but they're having this group of panels placed first, then they're going to go through the second group. If you have corners, you will have different arrangements to do. So they're placing 1, 2, 3, 4, yeah, because here we got a corner as well. So that's how they're going this way. And there are, as you can see, different placements if you're going to use the single casting or the stack casting process. After you tilt up and lift up the panel, they will typically be braced by special props, which we will be talking about a little bit more. Okay, so propping, that's what I was talking about. Propping, they are after whether you're going to get them craned from a factory or you're going to build them near sites. You will need to allow for propping, which is this. This is again, they are not custom-made members. They are typically supplied from a manufacturer who are going to be rating them for a specific height, specific force. What can someone tell me? What type of loads these props going to typically resist? Any idea? What type of force these panels going to be? These props going to be resisting? Yes, what are the lateral forces? What are they typically? Wind load. Yes, wind load, and that's right. Wind load would be the main force that would be applied to the panels and eventually the props. These props can be, one of the things you need to understand is they will need a proper supporting point in the ground. Now, it's again depends on your planning. If you don't have the slab already installed, then they need to come with their own heavy mass concrete, which this mass of concrete, again, they can be supplied by the manufacturer, but it's going to come with cost. If you had a better planning where you will be pouring your final slab, then you can prop it from the slab. But you have to make sure architecturally this won't be compromised, because maybe those temporary holes may not work good for the architect. And this is, you need to be very careful if the architect needed a special finish, concrete finish, then it won't be acceptable to have many voids there. Sometimes they will have a covering, like special paint or special tiles, then all this can be patched and you can then cover them up. So it depends on architecturally what's the nice finish, what's the last finish they want to achieve. And if this process it should be more economic, you don't need to allow for those temporary props. Sometimes what the builders think about, they may build a strip footing temporarily here to get those propped in case maybe this was a road here or asphalt, or maybe it's part of another a garden. You don't know what you have here. Maybe it's landscape. You don't have any structure. You will have a roof here in the future. Yes, that's fine, but maybe here you don't have any concrete in the future. So in this case, you have to go with those temporary blocks to help you stabilize what you have to stabilize. This picture here shows you the casting bars, the starter bars that will house the panels, which we will see more about such details in the engineering drawings. So you can see here they had some strip footings. Whether they're going to be permanently used or they were just temporarily done. These strip footings, if they need to be done temporarily, they will be really low-grade concrete, just for supporting that wind load. They won't be very heavy. They may only be mass concrete, just pouring concrete there for 600 by 400 wide, just to temporarily take the wind load. And then you will just keep it under the ground. And then you're going to cover it with soil or cover it with a slab, properly finished slab. So there are different thoughts needs to be considered at the base of those props. Sometimes it's acceptable to fix into a slab already, like industrial slab, and that was okay with the architect because they will have a special finish on top of it. Sometimes it's not, because the architect was after a polished concrete finish, and then these kind of many holes and fixings may compromise that aim. So really depends. It also, well, the point here is you need to go through these concentrations and go through these thoughts, because if it's missed, you may have issues and you may need to provide compensation for the arrangements. We have talked about this slide in terms of what we have here, but the component we're talking about now, it is the prop. The prop, as I said, is done by special manufacturers who got their own engineers who have pre-calculated the capacities. These props are flexible in terms of their height. They can come up with different heights, depends again on the design of for the precast. Usually they allow for 2/3 the height. Usually the panels is propped at its 2/3. So if the panel was 9 meters, then they're going to prop it at 6 meters from the ground. I would expect there is a pad footing here, temporarily built, if there was no permanent concrete here. So there should be a pad. They don't put the props into the onto the soil. They have to be on a rigid base. Some panels, if this was not working with this height, it won't take the capacity, so the manufacturer will suggest this optional knee brace. So this is just another element that will provide knee brace. They're going to place it here if required. Sometimes maybe this panel goes for 2 floors or 3 floors, so most likely it's going up for 2 floors, 6 meters in height, 8 meters in height, and if the wind was really heavy, those forces were really heavy, then you need a stronger prop, and to make it stronger, some of the suppliers can suggest having a knee brace here to give it much better capacity. Okay, there is also different detailing, which in this subject, basically you need to understand the use of a prop, but the propping details, you may not be asked about it, as you're going to see in the examples we're going to do during the workshop and for your assessment too. You just need to know the props will require a ferrule or fixings to allow for. And from one manufacturer to another, you may have different systems. So you can see here they also have oil hole to allow for extending the length of the prop. There are also some inspection holes. So this is really just up to the manufacturer how durable they want their props. Usually these are rented, not bought. It's up to you. If the major construction companies would buy them and keep them in their stores or storage areas, or sometimes they are for small, medium-sized builders. They will just hire them and let other companies worry about installing them. And these typically need to be checked and certified by inspection and special engineers who really check these props. So there are engineers who looked at what we call temporary works. We're going to be checking the placement of those elements, make sure their ratings are correct. So these panels will require, for example, maybe 10 kilonewton capacity, and they will just make sure the ratings are appropriate. Sometimes those props can be as cheap as just timber, right? In some projects, if they are really one single level, like 3-meter height panels, you can just prop them by a piece of timber, if the timber is okay with that, but you still need to fix it to a strong base like concrete pad or existing slab, and use a special anchors to do that. Maybe most likely going to be dynabolts, timber dynabolts, timber welding plate with dynabolts. Okay. This slide, what it is talking to you about, it is the shop drawings. So the story, what's this about? This is what I call to you a shop drawings. It is a drawings. It's not done by the engineers, not done by the architect. It's done by another contractor or another draftee. He's a draftee who works for the manufacturer. Yeah. So mostly the draftee who provide these drawings, he's going to be working for the precast manufacturer, or sometimes a contractor who works for his own. What they do basically, they gonna be taking the verified exact dimensions, not from the architectural drawings. We know the architect provide dimensions, but what they do here, they go on site. So you can see here, it's really up to the 10 millimeters. You can see typically those dimensions are very accurate, because they will go after they pour the slab and they place the main, they go to the site and do all the survey measurements to measure exactly what length needs to be done, because they're going to look to the architectural drawings and see where the architect, up to which room the architect want the panel to stop at, and see the exact measurements, how was the slab and the strip footing prepared. Then they're going to go and give the exact dimensions. Maybe the architect placed there 5.7, so the 60 millimeter was picked. That was the situation on site. And maybe the next panel was, so someone will ask, but don't the full length of the wall need to be correctly as per drawings? Yes, that's right. Some panels may be longer by 60 mil, but the other ones will be shorter by 60 mil. So that will work out to the final correct position. But to the final full length. But the shop drawings, they're going to give you almost the buildable correct dimensions. And again, these drawings will tell you where the ferrule is going to be placed to serve the construction process. They're going to tell you where the edge anchors are placed if required. Then also the draftee who does these drawings, they're going to look to the structural drawings like these ones that we're going to be practicing on. They're going to look to these drawings. They're going to work out the structural thickness of the panels. They're going to work out the steel required in the panels. They're going to work out the concrete grades required in the panels. And those people will write everything here to us. So you can see they talked about the steel here. They also have talked about the edge. Typically, the edge got special additional reinforcement. So the engineer will be reporting, can see here 1/16 central bar for all other 3 edges. So all those edges with cog, they should be placed around the panel. That's what the engineer specified. We're going to see this next week as well. So Wednesday, when we talk about this, you can see that's what the engineers provided here. They're telling the builder what to do at the edges. So it's asking for all the reinforcement detailing here. Also, if you have a window or a void, you have to allow for trimmer bars around it. And the draftee who's drafting these shop drawings is going to pick all those details. And they're going to get them ready to his client. His client going to be you, the construction engineer. So you're going to be, if you're managing a project, you're going to be asking for those panels to be built from a manufacturer. The manufacturer will have their own draftee to create those shop drawings. Those shop drawings will be done from the architectural drawings plus engineering drawings plus data surveyed from site. Then after they create maybe these documents, if you have really a large projects, they can be maybe up to 200 pages to review. So they're going to come back to you, which you need to review them. And then you will share them with the architects to review, and you will share them with the engineer to review, who mostly they're going to stamp them and say, yes, we checked them. But when the engineer is going to check them, the engineer will only check the steel. The engineer will only check the thickness. The thickness will be documented somewhere as well. They will also check the steel. They will check whether they got the right, if they have a steel beam to be fixed here. So they will also check if the plate is here, right? But the engineers won't be checking the dimensions. The architect will be checking the dimensions. But on top of that, you will also need to oversee all that processes happening as a construction engineer. So that's the story behind these drawings. So these drawings, they're going to be the key data and tools or documents that will let you, remember we were talking about make sure you everything is planned correctly. Reviewing these drawings is one of the main planning steps, right? Because they will ensure all those fixing details, and that can heavily compromise your the construction process are met. Sometimes, as I said, this is not the full page that will come to you. I can show you. There is another example. There is another maybe example for a shop drawing. Where is it? Here we go. This is kind of another one, but they just use CAD. This is just a shop drawing, which is doing the same job as per the previous one, but this is a bit more complicated. It's got rebate, which we will talk about maybe during the workshop. It's got a rebate to allow for the slab, the concrete slab, to sit on. So this one, what I'm trying to say, these shop drawings will give you more information about the thickness, and ideally they all should be like this. Also, the concrete strength should be written somewhere. And now this one talking about the weight, I was coming to this point, is the weight of the panels. That's nothing to do with the engineer, nothing to do with the architect. You are the construction engineer. You're going to be thinking about hiring a crane. So you need to work out a crane that will be able to carry the set of precast panels that will be driven to your site. So make sure that crane will be able to carry this load, right? The load can vary. The load can vary from one panel to another. So sometimes the panel, the drafty drone is bigger in size, so the size is actually bigger. And in this case, maybe one of your panels will be more than what the crane can take, and then you have to put them somewhere or ask. And these are one of the major issues can happen on site is accidentally when these shop drawings, as I said, can be up to 200 pages are reviewed by the construction engineer. They did not pick that some of the panels were very heavy and maybe only 5 of them. And when they came on site with a different patch of panels, you found 1 or 2 of the panels cannot be lifted. So that will let you cancel installing that panel, and it needs to go back to the site or placed somewhere. So it's really gonna be compromising the smoothness of the constructing the project. So careful thoughts need to be given to the weights. They all need to be within the acceptable range. So you don't need to bring a different type of crane every day or every time. It's just really gonna compromise the construction progress. So yeah, that was just another. So usually those shop drawings, they don't only give dimensions, they don't only talk about the construction, the structural engineering features and the architectural features. They also talk about details that will help you to make very, very important and costly decisions. For example, the crane type and size you need to have for the site. So that's where, that's basically I was talking about. Again, these drawings, we call them shop drawings, and they will be one of the main documents that will need to be carefully communicated between the team members and reviewed by all of them, right? And most likely it will be overseen by you as the construction engineer. Okay, so I think we can pause with these slides. We can finish the rest. Some of them are kind of, this section is talking more about the construction. So I will go through them over the first hour of the workshop. I kind of talked about most of these topics as you know, in my in today's lecture. I talked about most of these kind of arrangement. I've already talked about the lifting process, but I will go through them during the Wednesday's workshop. Maybe we take 1 hour or less to talk about these slides, and then we have one question to talk about, which is the last question, which will be a good timing for you to think about the precast panels, and maybe we have more time with your assessment. So in the following week, we're still going to be talking about the drawing. So I will go through the Wednesday. We'll finish those slides, maybe 30 minutes or so, and then I will introduce you, talk about these this example from this project, which is something related to your last question in your second assessment, which I trust you're working on now. Okay. So let's stop here and we'll complete the construction process or the construction details for the panels Wednesday. Any question before I end the meeting? Stop recording.